Hi everyone, this is Mohammad Aviz from automationplay.com. In today's lesson, we are going to use S7 communication between two PLCs. Here are my two PLCs, as you can see over here. I'm using put instructions in both PLCs to write to each other, and I'm using get instruction as well to receive the data. And further, I'm using data blocks to exchange and store data in those data blocks. So if I press my push button of PLC 1 from over here, my output in PLC 2 is getting on from input of push button 1, like that. So this is the task that we have to achieve in this section. We have to establish Profinet communication or Ethernet communication between these two PLCs. We are going to use get put instructions and further instructions as well. So in TIA portal we have S7 communication instructions in which we are going to use put and get instructions as mentioned in this manual. So these put and get instructions are used for sending data and for receiving data at the same time. It is exclusive for Siemens PLCs. We can communicate to S7 1500 to S7 1200 or S7 1500 with S7 1200 PLCs, and obviously we can communicate more than two PLCs as well using these instructions. So I'm using S7 1200, both S7 1200 PLC. This is S7 1211C DC DC DC, and this is 1200 1214C DC DC relay. So both have same firmware version. These are connected. Both are connected using this Ethernet cable, and my to the here's the black switch. So both cables are connected to this black switch, and from there my cable is coming and connected to my laptop. So let me open TIA portal. I'm using version 15 as usual. Let me run this as administrator. So let me create a new project from over here. Let me name it and click create. I can select devices from configure a device as well, but let me open the project view and directly drag the devices from the window. So I'll go to devices and networks. So I'll go to hardware catalog, and from here I can choose both of my controllers. First one is 1211C. Let me drag this one. Similarly, I'll select my second model, which is 1214C DC DC relay, having the same firmware version 3.0. So both PLCs have been selected. Siemens guidelines says that I have to click on connection, use S7 connection, and connect both the PLCs like that. So I'll go to S7 connection and connect both PLCs like that. So it shows S7 connection over here as well. It would show me in the network view as well, of course. After that, I have to go to properties of the S7 connection and configure some parameters. So if I click over here, let me drag that to right, let me go to properties. So S7 connection, my both PLC's IP is being shown over here. Local ID is 100. This is active. It should be active so that we can both send and receive data from both PLCs, and some address details mentioned over here as well. So local ID of the module connection is observed. We can change it over here as well, but by default it is 100. It is important that it should be ticked. So active connection means a two-way communication is configured. That means that you can set which connection parameters to take on active part and send and receive actively. So afterwards we can further individually set port get communication as well. But since I'm using version 3 of my PLCs, if I go to protection and security, so if I go to over here, so first of all it should be no protection, it should be ticked, and no protection from over here. Meanwhile, since I am using version 3, this option is by default activated in version 3. If I am using S7 1500 CPU or version 4 of S7 1200, I have to check that option as well. So it's all good from over here. One thing I would like to show you are the IP addressing. So if I click on search, so it is showing over here both the IP addresses of my CPU. And if I show you the IP addresses of my computer, here's my adapter. So as you can see, it is showing 192.168.0.50. So initial 3 defines my subnet, the same network, and the last one defines the node. So initial 3 should be the same and subnet mask should be the same for this Ethernet or Profinet communication. So initial 3 are the same. For my PLC 1 1211, it is 99 IP, 99 at the end, and for PLC 2 it is 1. So let me just change that from over here as well. So that was my 1214. It is fine. And if I go to devices and network, for this PLC it is 99. So I believe configuration is almost done. So now let's use port and get instruction. So first task would be that I will use port instruction and write data from my first PLC, PLC1, that is 1211C, to second PLC. So I'll go over here. I have S7 communication commands in communication. So S7 communication are exclusive for Siemens PLCs. For other devices on Ethernet, I can use open user communication. So I'll use port instruction, that is to push data to my other PLC, and later I will use get instruction to receive data from other PLC. So this will create its own data block as well, where it will store its parameters. So this is my PortDB instruction. We have two buttons over here, start configuration and diagnostic. We have some parameters over here as well. First, let me use this. So if I click on configuration, it is showing local PLC is this. I can select my partner PLC as unspecified or the PLC that I have connected. I'll select this one and it will automatically read all the settings. I'll use this active connection establishment and you can see the green check over here. On the other end, I have block parameters. So this is the important part. For the first one, starts the request for setup connection given by the ID. Here I can use clock pulse as well, or I can use some manual bit. For example, let me use M0.0 over here, as you can see, and it has assigned an ID to my port instruction as well. So there will be different IDs for different put instructions. So first one is write area address and second one is send area address. Write area is the address of the partner CPU where my data will be written. So let me use M10.0 over here, give me length as 1 and use int. So one int of data will be displayed from M10.0 onwards. The address from where I will send my data to my partner CPU. So here I will write the address that is on local CPU. Let me put over here MW1 like that. So as you can see, it has assigned a local address over here. This is displayed as P hash M10.0 int 1. P is pointer address that is being sent to my partner CPU M10.0 and int of data length 1. So I can use further done error status bit as well. For example, let me use over here M3.0, right? Yeah, so all seems fine. Let me download this program. So first it would detect my PLC 1 because it's shown show all compatible devices. So here's my PLC 1. I'll load this program. Let me go online. Right now I have taken nothing over here in my second PLC. Let me just take a tag and I'll assign it because I was taking M10.0. Let me assign just M10 over here. Sorry, data receive. Let me give over here as MW10. Let me put int as data type and let me download this program as well in my PLC2. Show devices with same addresses. So with this IP it would show the PLC over here. So if I go online, so my both PLCs are now active, as you can see over here in the network view. One thing I have to make sure that its active connection establishment should be checked. It's not right now. Let me just click check over here. Yeah, it's all done. Let me go online like that. Okay, so if I go to my main OP, display format as decimal so that I can monitor my data in decimal values. And for PLC2, let me open its tag table, put it to floating. So this is my address in local CPU, that is PLC1, if I write some value, it should go to my partner PLC of address 1 over here, which is data receive of PLC 2. So let me turn monitoring on. Let me modify value over here. For example, let me give 10 value, 10 as decimal. Yeah, fine. Now when I request, that should be active to transfer the values. So as you can see, 10 is being transferred or copied to my second PLC as well. Simple, right? Now what we are going to do is we are going to actuate some outputs of our PLC. Since we have just worked on this input and partner addresses, we can drag this down and take more addresses. So in one put command, I can use up to 4 send and receive addresses. So let me use my physical PLC input I0.3 like that, and let me use a pointer address p hash m20.0 bool space 1. So I have assigned the partner CPU address as m20.0. So as I press my push button, this bit would turn on. So by going to my second PLC, I'm going to create a simple program m20.0 and take output as q 0.0. So now I'm going to actuate my second PLC output from my first PLC input I0.3 to my PLC output, second PLC output q 0.0. So let me download this program. Let me take this online. Let me download this as well. And go online. So make sure when I click my main OB, if I click on diagnostic, both PLC connections are green over here. So if I double click it, it says S7 protocol, it's connected, configured static, connection is established, right? And make sure oops, so make sure these are connected. And if I go to properties, my active connection is established, both are green tick over here. So let's try to operate this. Everything seems good over here. So let me check my address I0.3 by pressing my push button over here. So yeah, it's coming, but my output is not on. Why? Because I have to turn my M0 bit as high. So my input is high, as you can see over here. And if I take this modify as 1, my output is high as well, like that. So my output is now on, and by using the input of my first PLC. So this was the basic program that I made. So as you can see, it has become, you can say, sort of retentive. I can further use a stop push button, like I have a red push button over here, this one, right? So let me try to use that as well to create a simple start stop circuit. Let me use I0.4 over here. Make sure to not use pointer addresses because this is my local CPU, and let me use p hash 20.1 bool 1 over here. Let me use m as well, like that. Let me download the changes in my PLC. And in my second PLC, let me use M20.1. So now let me try to actuate I0.4 to turn off my circuit. As you can see, my circuit has been now turned on. Let me start the circuit again. Let me make it true. It's on. Now if I turn this stop push button on, my bad, I'm using oops, let me turn this to true. Yep, so now it's working like that. So we have actuated second PLC outputs using first PLC input.